Hello and welcome to Astronomy Daily. I'm your host, Anna, and I'm thrilled to take you on a tour of the cosmos. Today, we've got a stellar lineup of stories. We'll be discussing Europe's plans for nuclear-powered space travel, an asteroid that's got its sights set on the moon, and a company that's planning commercial launches from Sardinia. Plus, we'll explore newly discovered giant radio galaxies and the infinite energy hidden in the vacuum of space itself. So buckle up and let's get started. First up, let's talk about getting to Mars. I mean, who hasn't dreamed of that, right? But it takes like forever. Currently, we're looking at about 9 months using the rockets we have now. But the European Space Agency, ESA, is looking into something pretty cool: nuclear propulsion. Now, instead of burning fuel and oxygen like a car engine, a nuclear reactor heats up a propellant like hydrogen and then shoots it out of the rocket nozzle. And get this, it's way more efficient than those chemical rockets we're used to. This tech could cut a Mars trip in half, from 9 months to just 4 or 5. Plus, the astronauts would actually receive less harmful radiation, which is kind of backwards. It sounds odd, I know, because the engine itself produces radiation, but think about it. Space travelers are constantly bombarded by cosmic radiation during their journey. So cutting travel time in half drastically reduces their total exposure. And of course, safety is a big deal. The reactor only turns on when the spacecraft is far from Earth in a safe orbit. Before that, the uranium fuel has very low radioactivity. And there are multiple radiation shields to protect the crew. The ESA team spent over a year analyzing this, and they think it's feasible. It's great to see Europe demonstrating its expertise, which could open a new era of space exploration. Now, let's switch gears and talk about asteroids. Remember asteroid 2024 YR4? It caused a bit of a stir earlier this year because it had a relatively high chance of hitting Earth. Well, it's back in the news, but this time it's about the moon. So NASA's been keeping an eye on this asteroid, and new data suggests there's a slightly increased chance it could impact the moon in 2032. Now, before you start picturing a lunar disaster, the odds only went up from 3.8% to 4.3%. Still not great, but hey, it's space, right? The James Webb Space Telescope actually played a role here. It was able to refine predictions of where the asteroid will be in 2032, which led to this updated probability. But even if it does hit the moon, don't worry, it won't alter the moon's orbit. So no need to panic. This whole situation is actually a good example of planetary defense in action. Scientists are constantly monitoring these objects, gathering data, and refining their predictions. And even though 2024 YR4 doesn't pose a threat to Earth, it's giving us a chance to rehearse how we'd respond to a potentially hazardous asteroid in the future. Silver linings, right? All right, let's head back to Europe, where there's some interesting stuff happening in the commercial launch sector. An Italian company called OLM, it's planning to offer commercial launch services from Sardinia. Yes, the island. They've actually gotten the green light to conduct small-scale engine tests at the Salto di Quirra military installation. This facility has a pretty cool history. It played a role in Italy's early space exploration efforts, hosting sounding rocket launches way back in 1961. OLM has teamed up with a German student group called Elara Aerospace, and they're working on a rocket called Starlight. Starlight is about 10.5 meters tall, has a diameter of 450 millimeters, and weighs around 1,000 kilograms. It's designed to carry a payload of up to 50 kilograms to an altitude of around 130 kilometers. And get this, they're planning to recover parts of the booster for reuse. That's pretty neat. They are hoping for suborbital launches as early as 2026. Now, for something truly mind-blowing, astronomers have discovered not 1, not 2, but 15 new giant radio galaxies. Yeah, you heard that right, 15. And these aren't your run-of-the-mill galaxies. These are the largest single objects in the entire universe. The discovery was made using the Australian Square Kilometre Array Pathfinder Telescope, or ASCAP, and the galaxies are located within the Sculptor field. To give you an idea of scale, these giants range in size from 3.7 million light-years to a staggering 12.4 million light-years across. Our own Milky Way? A measly 105,700 light-years wide. You could fit the Milky Way across the largest of these new giant radio galaxies, named ASCAP J01072347, more than 117 times. I mean, come on. ASCAP J01072347, which is about 1.5 billion light-years away, is especially interesting because it has 2 sets of radio lobes, one inside the other, like a nesting doll. These inner lobes are bright and short, while the outer lobes are faint and elongated. This structure could provide clues about how giant radio galaxies get so incredibly big. All right then, how do these things get so massive? Well, typically, a giant radio galaxy is a huge elliptical galaxy with a supermassive black hole at its center. When these black holes are feeding, they blast out powerful jets of matter at near light speeds. These jets create vast twin radio wave emitting lobes that stretch out for millions of light years. And it's believed that mergers between galaxies play a role in restarting supermassive black hole activity. When this happens, it recharges those jets, creating a second, brighter set of inner lobes. By studying these galaxies, astronomers can learn about the timescales on which these black holes switch on and off. Crazy stuff. All right, buckle up because this next bit is going to bend your brain a little. We're talking about the idea of infinite energy locked in the vacuum of space-time. Now, this concept comes from quantum field theory, which is basically where quantum mechanics meets Einstein's theory of special relativity. In this theory, particles aren't really what we think they are. They're more like fields that stretch across all of space and time. And these quantum fields, they have energy associated with them at every single point in space. So even in an empty box, you've got an infinite number of points, which means there's an infinite amount of energy in that box. Even when these fields are in their lowest possible energy state, their ground state, there's still an infinite amount of energy lurking there. But here's the kicker. We can't actually use this energy. It's like it's there, but it's not accessible. And that's because whatever its value is, it's the lowest energy state possible for the universe. Think of the Heisenberg uncertainty principle, which says that you can't know both the energy of a particle and how long it exists with perfect accuracy. This means that, at the ground state, particles can pop into existence for a tiny fraction of a second, borrowing energy from the vacuum as long as they give it back super quick. These are called virtual particles, and they're basically the manifestation of all the fundamental energies of the quantum fields that fill space-time. So, the bottom line is, this zero-point energy, it's the background on top of which all of physics happens. You can't go lower than the ground floor, so you can't extract energy from it, which means, unfortunately, we're going to have to stick to doing things the old-fashioned way for now. I think that in trying to explain that, I've made my brain hurt. And on that note, we come to the end of today's edition of Astronomy Daily. We covered some pretty wild stuff, didn't we? From Europe's nuclear-powered rocket plans to potentially slash the time it takes to get to Mars, to that asteroid that, well, might give the moon a little nudge, plus those giant radio galaxies. Seriously mind-blowing. And who could forget the head-scratcher about the infinite energy hiding in the vacuum of space? Thanks for joining me, Anna, on this journey through the cosmos. Don't forget to head over to astronomydaily.io, where you can sign up for our free daily newsletter, keeping you in the loop with all the latest space and astronomy news. Our news feed is constantly updated, so there's always something new to discover. And, of course, make sure you subscribe to the podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. That way, you'll never miss an episode. Catch you next time for more Astronomy Daily. In the meantime, keep looking up. Bye.